All right, here's our last video of section 2.1. I know we've talked about a lot in this section. We've talked about the three different ways of representing sets: roster method, word description, and set builder notation. We've talked about a couple of different notations, elements of, empty sets. We've talked about inequalities, natural numbers. Make sure you go back and review some of the main things that we've talked about before moving on, doing your homework, and moving on to the second section. In this last video, though, we're going to talk about what we call equivalent sets. Equivalent sets are sets that contain the same number of elements. The notation that we use for equivalent looks like this. Remember, this n of a means that you have a certain number of elements in your set. Remember cardinal number? And if a has the same number of elements as b, we say that they're equivalent. So an example would be if set A was a set of all x's such that x is a vowel. That's A, E, I, O, U. That's 5 different elements. And if set B was the set of all x's such that x is an element in the natural numbers, where x is greater than or equal to 3 but less than or equal to 7. That's 3, 4, 5, 6, 7. Set B also has 5 elements. Even though they have nothing to do with each other, one's letters, one's numbers, we can say that set A and set B are equivalent to each other because they have the same number of elements. Okay? Another different definition we're going to talk about is what we call finite sets, where set A is a finite set if the cardinal number is 0, it's an empty set, or a natural number. So if it has numbers in its set and stops. Where an infinite set is a set that continues to go on and on and on and on forever, right? So we have an infinite set where you have elements that go forever, and we have a finite set where it kind of stops at some point. All right, the last little thing we're going to talk about is what we call equal sets. Now remember, we just talked about equivalent sets, where equivalent sets are sets that have the same number of elements. Equal sets mean that they contain the exact same elements, regardless of order or possible repetition. If they have the same exact elements, then we say that they're equal sets. The notation we use for that is just an equal to sign. Set A is equal to set B if they contain the same exact elements. Let's do an example to make sure that we understand the difference between equivalent and equal. If you look at example 10 with me, it says determine whether each statement is true or false. Part A says that we have 2 different sets, and it's asking if these 2 sets are equal. Well, in this first set, we have the numbers 4, 8, and 9. In the second set, we also have the numbers 4, 8, and 9, don't we? Don't they contain the same exact elements? And so we would say that these 2 sets are equal. That is true. Now, we could also add to that discussion, and I could say, well, are these 2 sets equivalent? Maybe using this notation, right? Well, remember, equivalent means they have the same number of elements. Well, how many elements are in this set? 3, right? And how many elements are in my second set? 3, right? Well, then couldn't I also say that these 2 sets are not only equal, but they're also equivalent? So this would be an example of these 2 sets being both. They are both equal and equivalent. They have the same number of elements, but because they have the same exact elements, they're also equal. Look at B. B has the set that contains the element 1, 3, and 5. The other one has elements of 0, 1, 3, and 5. They not only have different amounts of elements, so they're not equivalent, they also don't have the same exact elements. So we would say this statement is false. They are not equal because they don't contain the same exact elements because there's an extra 0 here. And because this has 3 and this has 4, they're not equivalent equal either. They're not the same amount of elements. So this is not equal or equivalent. Look at the next one here, C. It says set A has elements 2, 4, 6, 8, 10, and set B has elements 0, 6, 4, 2, and 8. I want to ask you 2 questions. I want to know if these 2 sets are equivalent and are they equal. So we have to make sure we know the difference between the 2 different vocabularies. Remember, equivalent, let's start there. Equivalent means they have the same number of elements. Well, if I look at this first set, set A has 1, 2, 3, 4, 5 different elements. Set B has 1, 2, 3, 4, 5 different elements. Since they both have 5 elements, I could say that they are equivalent because they have 5 elements each. Even though they might not be the same elements, they have 5 elements, so they're equivalent. Now, are they equal? Do they have the same exact elements in A and B? Well, they're a little bit different, so I'm going to say that A and B are not equal. They're equivalent, but they're not equal to each other, making sure that you can use that proper notation as well. I want you to add one more to your notes. I want you to add D. I want you to say that set A is 1, 2, 3, and 4, and set B is 1, 1, 2, 4, 4, 3, 3. And then I want you to answer 2 different questions. I want to know if you think these 2 sets are equivalent or if they're equal, and if they're equal, right? Equivalent and equal. Write that down, pause the video, and answer the 2 questions for me. Is set A equivalent to B, and is set A equal to B? All right, looking at set A, I have 1, 2, 3, 4 different elements. So I would say that the cardinality of A is 4. There's 4 different elements. Looking at set B, I have 1, 2, 3, 4 different elements. Yeah, there's some repeating, but there's still only 4 different elements. And so because A and B both have 4 different elements, their cardinality is both 4, then I can say that A and B are equivalent using this notation because they both have 4 elements. Now, are they both equal? Do they have the same exact elements in each set? Well, to me, set A has the numbers 1, 2, 3, and 4, and set B also has the numbers 1, 2, 3, and 4. Again, some of them repeat, but it doesn't really add anything different. So I would say that these are also equal to each other. They have the same exact elements. They're equivalent because they have the same number of elements. They're equal because they have the same exact elements. All right, lots of different notation and definitions we've talked about in this section. Make sure that you go back, review, practice if you need to, watch the video again if you need to, and then make sure that you're doing all of your homework to make sure that you fully understand. Let me know if you need anything.